Hello and welcome. In this video, we're going to look more into our KCL and current division expectations. So I've written out a couple of them over here that identify what's going to happen based off of our resistance. If the branch resistances are equal to each other, then the current will divide equally. But if the branch resistance has a smaller resistance, then we expect a larger current flow through it. And if we have a larger resistance, we expect a smaller current flow through it. So we can use that to identify how our circuit is going to process this. So we are going to trace through the nodes of this circuit here, and we're going to identify I1, I2, and I3 currents. We see those in here, I1, I2, and I3. And so from the start of our circuit at the top here, we see 12 amps entering the node, and we have 9 amps entering the node, and we have 4 amps entering the node. Right, so all of those are going to have to leave the node, and we see the only pathway to leave the node through is going to be out towards R1. So whatever we leave this node with is going to be our I1 current. And we need to algebraically sum those together to be able to identify how large that current is. So we'll take our 12 amps that we know is entering, we'll add that to our 9 amps that we know is entering, and we'll add that to the 4 amps that we see there too. And that gives us 25 amps leaving that first node, which means that 25 amps is flowing through R1. And so we'll call that I1, 25 amps. And that means when we continue through the circuit, that current cannot change direction. So now we know that that 25 amps is also entering the next node. Right? We also see that the 4 amps across the top here is entering the node. And now we even have a 6 amps leaving the node right here. And we know that whatever is left over is having to go down towards I2. So I2 should be the algebraic sum of those values. So let's send this out. So we know 25 entered. We'll add that to the 4 amps that entered as well. We'll subtract out the 6 amps that we know left, and that gives us 23 moving forward. 23 amps is leaving this junction node, which means that that is going to be equal to I2. I2 equals 23 amps. Right, and as we move through this, we know that that current cannot change direction, so it's going to go straight through R2 and enter into the next node. So that's entering the node. We see that we have 3 amps leaving the node here, and we know that I3 has to have whatever's left over. So we're going to use that to solve out for that one. We know we started with 23 amps entering in. We are going to subtract out what we lost, that 3 amps, and we'll be left with 20 amps leaving towards I3. So I3 is equal to 20 amps. Let us know if you have any questions.